Hi, this is Sharon from AMACO Brent. In this video, we're going to demonstrate how to troubleshoot your Brent Potter's wheel with a silver face controller. These were on wheels sold between the 70s and the early 2000s. This troubleshooting video involves working with live electrical circuits. Please only perform these steps if you are comfortable doing so. You can always send the components from your wheel to your local distributor or to AMACO directly to be diagnosed and repaired. With that being said, there's a blue capacitor found inside the older CXC model controllers. It is the only component that can hold a charge even after your wheel has been unplugged. Do not make contact with the metal leads of the capacitor at any point. Be sure not to plug your wheel in during this step or anytime you see this symbol. Flip the wheel on its backside for ease of access and begin by removing the controller with the two mounting bolts holding the controller onto the frame. Flip your controller to the cord side and locate where the motor and foot pedal cords enter the controller box. Use a pair of adjustable pliers on the larger setting to remove the strain relief clips. Squeeze them in a vertical position with the pliers and pry downward. Remove the strain relief clip for both the motor and the foot pedal. Remove the screws from the corner of the faceplate to open the controller. Again, make sure your wheel is unplugged. Remove the fuse by pushing the cap down and rotating counterclockwise. Pull the fuse out of the cap and check that it has continuity. I'll be doing this with the continuity meter. Always check that your diagnostic equipment is working before use. This simply lights up when it completes a circuit. Touch it to both ends and ensure that it lights up. Put the fuse back in the cap and press it into the fuse holder. Rotate clockwise until it clicks. Open the front face of the controller and you'll see the following: the on and off switch, the fuse holder, the ground, where all the ground wires connect to make contact with the metal component of the controller, the bridge rectifier, which converts the alternating current from the wall plug to the direct current the motor needs to spin in one direction or another, and the D30 control, which converts the signal from your foot pedal position into how much energy is provided to the motor, resulting in how fast or slow your wheel head turns. If you follow the foot pedal wire into your controller, you'll see where it hooks into the D30 control and the common ground. If you follow the motor wire into your controller, you'll see where it hooks into the bridge rectifier and the common ground. And if you follow the power supply cord into the controller, you'll see where it hooks into the fuse holder, on and off switch, and the ground. We'll be using the continuity meter again to test if the power supply is able to flow to all the different components inside the controller. Clip the continuity meter to the neutral prong on the plug. Follow this cord where it comes into the controller. We'll be following the neutral white wire. Each point in the following sequence should cause the continuity meter to light up. Touch the in and the out of the on-off switch. If this doesn't work, make sure the switch is in the on position. Now touch where the white lead connects to the D30 control. And finally to the bridge rectifier. Touch the metal just below any insulated connectors. If all of these points light up, you have adequate electrical supply for the neutral leg of your power supply. We'll now switch the multimeter clip to the hot prong on the plug. Follow this cord where it comes into the controller. We will be following the hot black wire. Touch the in of the fuse holder. Touch the out of the fuse holder. Follow that to the on-off switch and touch the in and the out. Follow that to the D30 control. This is a tight squeeze, so I follow the connection through the board and touch the back side. If all of these points light up, you have adequate electrical supply for the hot leg of your power supply. Locate the motor wire and where it comes through the control box. Unplug the white and black wires where they hook into the bridge rectifier. Make sure the motor connection stays out of the way. We will be plugging in the controller during this step if you're comfortable with exposed electronics. Be cautious of the live circuit and do not touch the wires or internal components while performing these next steps. Make sure the foot pedal is fully engaged. We're going to use the multimeter in the DC or direct current setting for voltage. Carefully touch each probe to where the motor was connected on the bridge rectifier. You should get a reading of around 100 volts. Switching the probes will change that similar number from a negative to a positive or vice versa. Unplug the wheel for the following steps. Completely unplug the motor connections from inside the controller and feed them through the back. Grab a 9-volt battery and use your multimeter on the DC or direct current voltage setting to measure that it still has around 9 volts. It can be positive or negative. We're going to use this 9-volt battery to test the motor, but we want to make sure that it works before assessing something as expensive as a motor. Touch the black and white leads to the 9-volt battery terminals. Watch to see the motor shaft turn slowly. Flip your battery and watch the motor turn in the opposite direction. If this functions for this test, your motor is not the culprit. Feed the motor wires back through the controller box and reconnect. We're now going to test the foot pedal. Completely unplug the foot pedal connections from inside the controller and feed them through the back. Some multimeters aren't able to measure the sensitive resistance circuit of the foot pedal. For this measurement, I'm going to use a multimeter that can measure ohms with a 2000K setting. A properly functioning foot pedal should measure a resistance of around 150K ohms on the full speed setting and around 350K ohms in the stop position. Yours may vary, but you should see a few hundred ohms difference between stopped and full forward. Feed the foot pedal wires back through the controller box and reconnect. Make sure the strain relief clips are reinstalled. It can be easier to use pliers just to seat the clip and use your hand to push it in the rest of the way. Be sure to check your cords after you've reinstalled the strain relief clips. Anytime you've opened an electrical box, always check every connection before closing. If you have any questions, don't hesitate to reach out to our technical support team at 800-999-5456 or email customercare@amaco.com. You may also use this phone and email to request sending in your controller and foot pedal for diagnostics and repairs.